All right, so we're talking about reflections today, and I've got you guys, you've got your graph paper folded. We got 4 different graphs here, and we're looking at what's in common. Will, what'd you say? What was in common with all 4 of those equations?
Negative.
The negative sign. So the negative sign is what tells us we're going to be doing the reflecting, okay? Now, we transformed first by sliding. Is that correct? We slid first, and that's what you're going to do. You're going to slide first. Then, what are you going to do? Now you're going to reflect. Okay, we're kind of going in the order in which you would actually perform these guys. Okay? So we're going to go ahead and reflect. And sometimes you can reflect first and then slide. That's okay too. But anyhow, well, here we are. If the negative is on the outside, as it is in problems 1 and 3, that means something special. If the negative is on the outside of the radical, outside of the absolute value, that means you're reflecting upside down. Okay? So those mean we're going to go upside down. So if we had, let's say, a parabola, if you had a negative outside of the x, negative x squared, it's going to be an upside down parabola. Okay? If we had a high v, like we do in number 3, where the negative is on the outside, what does that mean? Upside down v. Okay, that's all that means. High v, low v. Okay? What happens when I have the negative sign inside the radical or inside the absolute value? What do you think we're going to be reflecting this time? We're going to be reflecting left and right, or across the y-axis. Sometimes I write it this way. We're going to be reflecting like this. Kind of looks like a division sign, but it's just showing you it goes from one side to the other. Upside down means you're going to be reflecting one upside down like this. Upside down or left and right. Okay? It's all in where the negative sign is. Okay? So, let's start by graphing the parent, and then we'll move it around. So, the parent for this function is, if you remember from your parent function quiz, it just goes to the right. Up, what's the square root of 4? 2. What's the square root of 9? 3. So this is my parent. Okay? I'm going to get my game on, and I'm going to go upside down now. Literally watch. 0, 0 stays the same, but I'm just going to go upside down. Every point is just across the x-axis. So my actual answer, it looks like if you graph them together, that it's, but that is the actual answer, what's highlighted. Only what's highlighted, because the black graph, the original graph, the parent function is just where I started from. But if I'm going to graph, and if you want to use your calculator to see, if I put a negative square root of x, it's just going to give you that bottom half, that upside down. So try it. Again, if you have anything in there, go ahead and try to graph the negative square root of x. Hopefully you'll see that's what you get. Oh, I should zoom standard. Okay, just that bottom half of the graph. So rather than 1, 1, I have 1, negative 1. And then I have 4, negative 2. 9, negative 3. Okay? So please make sure on your paper that you're very clear about which is your final graph. So you want to use different colors. So you want to make sure that you darken it, you highlight it, you really are obvious about what is the only graph that's the answer. And it is only the bottom half, right? Okay, go ahead and try number 3. Sometimes we'll get to the point where I don't have to graph the actual parent first, and I just know that since this means an upside down v, that's all I have to graph. So if I know just by looking at the equation that this is what it's going to look like, then I know that that's all I have to graph. It's just simply upside down. And so sometimes you don't have to graph the parent. We'll eventually get there, okay? So you can just graph the actual low V, because that's what that means. Okay? Again, the negative outside simply means that. You can graph reflections and translations, or reflections and slides, in any order. I can go upside down first and then slide around. Okay? Or I can slide around and then flip it. I personally think you should probably flip first and then slide. I think that's probably the best way to go, because then we'll just make it that way, because that way you can reflect across the x-axis specifically every time. Any questions about how to go upside down? You're inverting the dirt, okay? You're inverting it upside down. Now, what do I mean about over here with the negative on the inside? It says across the y-axis. I go the other way. So instead of graphing, well, let me start with my parent over here. And again, we'll start with our parent at the beginning. And that's my parent. But if I want to get my final graph, what's it going to look like? What direction is it going to be flipped if the negative is underneath? It's going to now go this way. Okay, it's going to go to the left. So again, same points, just going in the other direction. So when the negative sign is underneath the square root, we flip across the y-axis. Make sure you're putting arrows at the end of these graphs, because they do continue. They don't just stop. And they look like this. I'd like for you to try number 4. Okay? Let's graph that last one. What is that going to look like? So you guys are right. If I graph the parent here, we know what this looks like. It's our high V. Okay? If I flip this across the y-axis, in other words, if I take the right-hand side of this and I flip it on the other side, what does it actually become? What's already there? So it's kind of like I'm flipping it across itself. Or flipping it and ending up with itself. So this one, actually, the parent and this function are the same thing. That's rare. It doesn't happen all the time. Okay? You won't see it very often, but it does, in fact, happen. So what I'd like us to do is I'd like us to try some of these reflections. So if you guys would, we've already done number 8 in your packet is one we've already done. Number 2 in your packet is these 2 graphs, by the way. I'd like us to 2 and 8 in your packet are the ones on the board. I'd like us to try number 6. So if everyone could go ahead and look at question number 6 for me. Okay, look at question 6. So what is the parent on yours of this particular function? That parabola, U-shaped, okay, that's our parent. Because it has a negative there, I think rather than graph the parent, can we just start with it upside down? Is that okay with you? Because let's go ahead and start with the reflection. So what I mean is this. We know the shape of the U. Normally it goes up, right 1, up 1, but this time we're going to go right 1, down 1. It goes right 2, up 4, but rather than up 4, we're going to go right 2, down 4, left 2, down 4. So this is really y equals negative x squared. Would you agree with that? I just flipped my parent upside down. Okay? So I have taken into account, for now, this sign only. I've just flipped it. I'm not finished yet, because now I need to do what? I have some other transformations to complete. What else do I need to do? Right 2, Christian? It is right. It is opposite, because negative normally means left or down. So because it's inside, it means right 2 in this case. This is right 2. On number 6? Yeah, 6, sorry. Okay, so number 6. So right 2, and then what else do we do? Right 2 and down 3. So from this upside down parabola, that's what we're going to do. We're going to move each of these points right 2 and down 3. I like to start with 0, 0. Right 2, down 3. And then I'm just going to continue my pattern from there. And my parabola is right 2, down 3. And so what I'm about to highlight is, in fact, the final answer. I went right 2, down 3. Make sure that you're using a colored pen or something of some sort to know which graph is your final answer. You should try to plug it into the calculator. Make sure it matches. Does it match what we're doing here? Plug it in. Let's try it. Don't touch that. It's good.
I thought that was the calculator.
It's right here. So let's plug it into the calculator. Negative, parentheses, x minus 2 quantity squared minus 3. Let's see if it's not what we think it is. It does match, doesn't it? The calculator matches exactly what we thought it was. You want to flip first, and then you're going to slide it around. Okay? Flip and slide. So that could be part of our dance too, flip and slide, right? Right? We can add that. So here's what you need to do. For homework that's due next class, you need to finish, Matthew, do you mind if I borrow yours for a minute? You need to finish all of them except for 16 and 17. So you can skip 16 and 17, but you need to finish everything else. Okay? Because we haven't done them when they have the number in the front, not the back. I'm sorry, just 1 through 18. So it's going to be basically 1 through 15 and 18, because you're skipping 16 and 17. The back we're going to do on Monday or Tuesday. Okay?